guys, how are you today? Today we're going to go through the second session. It's about how to find some properties of an exponential function. Some people call it indicial function. All right. First of all, we have a function called f of x, 3 to the power of x minus 9. Let's find some properties of that function. Any function should and could be having an x-intercept and y-intercept. All right. So let's find the first thing about the x-intercept, or let's talk about the y-intercept. Whenever you see the word looking for y-intercept, then you should realize that x is always 0. This is a fact. You should know that. So when you plug in there, y equals 3 to the power 0 minus 9, and 3 to the power 0 is how much? 1 minus 9 is negative 8. So the coordinates in this situation of the y-intercept are 0 and negative 8. Okay, that's a cool one. Remember last lecture we learned about dealing with basic exponential rules. So let's go number 2. What is the x-intercept? To find the x-intercept, realizing that y equals 0. There's no game about that. So let's plug in there. This is y. 0 equals 3 to the power of x minus 9. How can I solve that? Why don't you take the 9 to the right hand side or left hand side? So this was taken over there. Now you can see the base is 3 here. If the base is 3 here, what is the key here? Make it the same base. To what power? Try your calculator. They are 3 squared, so x equals 2. So coordinates in this case, there are 2 and 0. 2 and 0. That is called the y, the x-intercept. 2 and 0. Okay, what's the special thing about exponential function? It has an asymptote. What do you mean by an asymptote? We will help you out what does it mean when we draw it. So number 3, in order to find the only thing which is called the horizontal asymptote, simply it's the equation of the asymptote, and always is the number is either subtracted from the exponential one or added to it or 0. So since all horizontal lines are called y, then the equation of that one is y equals negative 9. So far we have done 3 things. We find the main features, the y-intercept coordinates, the x-intercept coordinates. We should be good a little basic of exponential simplifying thing, and then there's the asymptote. What else we need? Let's have a sketch of that. All right. This is my y. This is my x-axis. And my 0, negative 8, somewhere on the y-intercept on that thing. So this is negative 8. There is no point to say 1, 2, 3, 4, 5. It's a waste of time. Make it proportional. What is that? X-intercept. Well, if that's 8, that's 8. That's 4, that's 2. Ah, cool. This is 2. What is the y-intercept? Y-intercept means, the horizontal asymptote means where you cross the y-axis. So where would you cross the y-axis? If that's negative 8, this is negative 9. This is called your horizontal asymptote. It's a hidden imaginary line that you cannot touch, you cannot cross, you can approach. So ladies and gentlemen, your curve is, you cannot come like that. It is simple and exponential curve. So you're going to go all the way there, smooth and smooth and smooth, as x is approaching negative 8, negative 8.1, negative 8, negative 8.9. What is happening to the y? The y is coming so close, but you don't touch the axis. This is your exponential function. So as x coming very small, the y is coming so close to what? To negative 9. This will help me in 2 issues. The first issue, that's how you sketch the curve. From sketching the curve, I can find something called the range. And how can I find the range of that curve? You can tell range means y from the word ranging. Everything above -9 goes all the way to heaven. So your range, all the possible values of y that are larger than -9. I can write it a different way. Or I can say -9 is the smallest one and it's all the way up. Don't forget, these are called the y values. This little abbreviation means all the values of y that belongs from -9 until further y. Some people maybe feel a little bit curious, how can I find the domain? Actually, the domain is so simple, nobody talks about it, but it's all the way that way, all the values of x and all the values of x that way. So we can simply say x belongs to R. If you don't like that word belongs to, it's from -infinity to +infinity. So, ladies and gentlemen, that's basically some properties of one of the simple, very simple exponential function, power function, indicial function. Indicial is coming from index, indices. The adjective is indicial. So we found the y-intercept by looking at x equals 0. We found the y-intercept by looking at y equals 0. And there is always horizontal asymptote. This line is called the horizontal asymptote. Its equation is y equals -9. The equation or the function is called f of x, which is what? 3 minus 9 to the power of x. Now, this has been plotted properly, perfectly, is enough. Let's go for a second example, or another example. Little bit hard, with some fractions. All right, gentlemen? So these are the main properties of such a function. I'm gonna draw it all, clean it all. If you don't understand it, there are 3 examples in your exponential function lecture notes. All right? And they are all there for you. So let's look at that function over there. It's called an exponential function. How do we know exponential? The x is in the power. All right? So first of all, what would you like to do? Actually, I like to do the equation. How about if I do it differently? The equation of the horizontal asymptote. It doesn't have vertical, horizontal. The equation is quite clear. Any number, add it to this or subtract. So I can write this one that way. Or I can write it that way. All right? It doesn't matter. If you wish, let's make it simple for everybody. I'm going to make this function like this. That's a bit different, but I don't want to go into hard details. So your horizontal asymptote is the number that comes after the exponential, whether added or subtracted or 0. Y equals -81. La ilaha illallah. All right? I don't want to go to the details of reflection in the x and the y axis because that's beyond our domain. Number 2. How may I find the y-intercept? If I'm looking for the y-intercept, then I have to do what? Take x equals 0. Remember that one? Let's plug it over there. Y equals 1/3 to the power of 0. It's a 1 times 3 is a 3 minus 81. So what is 3 minus 81? I think 78, but it's a negative. So all of this is the 3 minus 81 and it's 78. Negative 78. All right, that's the equation or that's the coordinate. Actually, the ordered pair is 0 and -78. Numbers are huge, so what? Number 3. How about the x-intercept? X-intercept means what? Y equals 0. Well, let's try it then. This is y equals 3 times 1/3 power of x minus 81. What can we do about that? Let's solve it as usual. Take the 81 to the left-hand side. This is multiply. Maybe to make life easy for everybody. Yes. So what is 81 over 3? I think it's 27. Yes, I hope I'm not wrong, because I do stupid mistake like anybody else. I can play with both bases. You can see a question like this in your exam. Solve that equation. Simplest question like this. It says, solve. That's supposed to be an easy part. But guess what? Our third lecture is about solving exponential equation. The 27, I can make it 3 to the power 3. Well, how about that one? This is 3 to the power 1. Take it up. It's going to be 3 to the power minus 1 all to the power of x. And 1 is 3 to the power 1 all to the power minus x. It's 3 to the power negative x. Now, since the bases are equal, then I will have to equate the powers. Minus x equals 3, x equals negative 3. All right? So the coordinates of the x-intercept are negative 3 and 0. So you got to be good in algebra, guys, ladies. Number 4. What am I looking for? Equation x-intercept. Oh, let's sketch it. Let's see sketching it. Because from the sketch, gentlemen, ladies, you can get the range. Yes, you can do it, but let's talk about it further better that way. So I'm looking for y equals negative 81. Woo! This is negative 81. You don't have to start saying y equals negative 81. That's the point, negative 81. Ta-da! 0, negative 78. Well, if that's negative 81, that's negative 78. And the other point is negative 3 and 0. Where is that? Well, if that's 78, this somewhere here is supposed to be negative 3. All right? So, guys, the curve coming all the way from up and smooth down. That's not a straight line. To tell you the truth, that's simply a smooth curve. Do not touch the x-axis. Don't touch. So what's the difference between this curve and the curve before it? This is called a decreasing function. That's called a decreasing function. Well, you have to know why. As x values comes larger and larger and larger, like 1, 2, 3, 4, what is happening to the y? The y is coming less and less and less. Some people say, I don't see that one. Okay, at negative 1, the answer, let's say negative 10. But when it's 2, the answer is less. As x becomes large, the y becomes what? Closer and closer to negative 81. It means come smaller. Some people don't like this because we can use this definition in the math too. But there's another secret. Look at the one over there. 3 times 1/3 x minus 81. And look at this game. 3 times 3 minus 1 to the power of x. Last shot. 3 times 3 to the power minus x. If the exponential power is negative, that's decreasing. So you have another reason. Power or the index is negative. That's why we call it decreasing. How about the question before it, a while ago, which was 3 to the power of x, if you remember? The question before it, 3 to the power of x minus 9. Is that an increasing function or decreasing? Now you can tell why it's increasing, because the power is positive. If the power is positive, means what? As the x increases, the y very, very much increasing. Look, we are living this situation in some of the countries in Europe. Because of the disease of corona, as the number of, what can I say? The more people are getting the corona, they are dying fast and fast. That's called an exponential increase. Cannot be controlled, but now they are controlling. Like nuclear bombs. The minute you hit the bomb, it automatically, the power increases so fast. That's called an exponential increase. India has an exponential increase in birth. China, they are controlling it a little bit. Anyway, the last idea about that thing is how to find the range. You can tell the range, it's minus 81 and above. How can I say that? Minus 81 and all the way to infinity. This is your range. Minus 81, minus 80, minus 70, minus 30, minus 20, 0, 1, 2, 10, 12, 1 million. This curve goes all the way up. All right? That's what I need to talk about at this level. Two simple functions. One of them was easy, one of them a little bit open. You go back to your notes, you find another three functions. You've got to read them first before you come here. Let me clean everything. So, gentlemen, that's your second step. Your third step is how to solve exponential equations. Exponential equation can go so hard that sometimes you have to think. But with the rules you have, shouldn't be any harder. Let's start with something simple. What is the question here? Solve the following exponential equations. Let's start with question number 1. 5 to the power of x equals 125. How can I solve it? Make this the same base as that one. So x equals 3. Why I'm doing it fast? Because in the last lecture I gave you 2 examples, supposingly that you've seen it. Let's take a bit harder one. Let's say a to the power of x equals 16. How can you make one of them same base? You can't. Therefore, I can play with the a to the power 3, and I can make the 16 4 squared, but it doesn't work. But I can make it 2 to the power 4. Same base, gentlemen. What's 2 to the power 3 to the power x? Is 2 to the power 3x equals to the power 4. So, if the bases are equal, the powers are equal. Then divide them both by 3. All right? Something very silly, something very simple, but I don't want something hard. I just want to make sure 5x minus 3 equals 1. How can I make the one base 5 like that one? Think about it. What to the power of what gives me 1? The only number is 5. I reviewed this for you last time in the lecture number 1. So 5 to the power 0 is 1. If they are the same base, therefore x equals 3. So if bases are equal, you have to equal the power. Take number 4. How about if I have 7 to the power 3x minus 1 equals 1 over 49? You think this is hard. That's not the game. The click here is to look at the 49. The 49 is what? It is 7 squared. Lovely. But I cannot solve it. One numerator, one denominator. So what do? Take this one over there. 7 to the power negative 2. Ha! Here we go. Bases are the same. Powers must be equal. So, ladies and gentlemen, 3x minus 1 equals minus 2. If you have problem in algebra, God forgive you, but I will not forgive you because haram. You make mistakes till now. Negative 1 and x equals negative 1 over 3. So you're going to be good in algebra, dear friend. You're not good in algebra? Oops. Let's put something that we've already learned. Like what? Number 5. 3 to the power x times 3 to the power, let's say 2, equals 81 to the power of x over what? Let's say 27 over x minus 1. Ooh, scary. It's not. These are the same base. When we multiply, we add the powers. We said that last time. These are not the same base. Let's make them same base. 81, 3 to the power 4. 27, 3 to the power 3. Let's expand the bracket here. 3 to the power 4 to the power x means 3 to the power 4x. 3 to the power 3, we multiply the powers. We expand the power. We said that in the rule. Which rule? This rule. X to the power a, all to the power b. It's an x to the power ab. So remember that. Don't memorize rules. Solve and reason and then ask questions. So it's going to be 3 times x, 3x. 3 times 1 is negative 3. On the left hand side is that one. I've got to make those one base. One power. How? When we divide, what do we do with the powers? We subtract. So let's take the top one minus the bottom one. Don't forget, when you divide, you subtract. Put brackets so you can focus. Don't just write, oh, I don't understand. You gotta do it step by step. Let's subtract. 4x minus 3x is an x. Minus times minus, it's a plus 3. Wow. Here, x is plus 2. If the bases are equal, go ahead and use the powers x plus 3. And guess what? That question will end up to be wrong. Why? Because I just made it up. And you know, 0 cannot be equals 1. Because it doesn't make sense. But anyway, we wouldn't do that in the exam. We will give you something that it works. We will study it, we'll double check. We have a nice team in the ACK. We always check for each other. But now, because I'm trying to use my time in this video wisely, let's take something very sneaky. Question number 6. How about if I say a to the power x squared equals what? 64. What? Powers, square root. Why it look like this? Well, think about it. Can I make this 8 squared? Yes, I can. Wow. So the base will stay. In here, it will go like that. So stupid. But you didn't think about it, right? The bases are the same. X squared equals 2. X equals square root of 2. Am I right? No. Because you forgot that when it's a quadratic, you have 2 roots. It's got to be 1 plus 1 minus. You're going to keep forgetting this until you are a nice guy. How about we take question number 7? Let me find something beautiful. Ah, that's beautiful. No, I know that. So let's take something hard. 81 to the power of x over 3, okay, equals 9 times 27 to the power 3x. So you can see everything is a base of 3. Can I prove it? Yes. 81. 9 times 9. The first 9, 3 squared. The second 9, 3 by. So how many 3's? There are 4. So you're going to say 3 to the power 4 times x. Wow. How about that one? The 9 is 3 squared. All right. That's cool. How about the 27? Actually, the 27 is 3 to the power 3 and times 3x. What is 3 times 3x? Is a 9x. So, gentlemen, 3 squared times 3 to the power 9x. What do we have over there? We are having 3 to the power 4x down there to the power 1. Now, let's continue here. When we divide, what do we do with the powers? We subtract. So, 3 to the power 4x minus 1. What do we do here when we multiply? When we multiply, we add the power. So, 2 plus 9x. Now, do we agree the base are the same? Yes. So let's take the powers. 4x minus 1 equal 2 plus 9x. Put the x's together. I'll take this one over there. 9x minus 4x is 5x. Please don't call me in the middle of the night. How to get the 5x, okay? Hey, take this one over there. Negative 2, negative 3 equals 5x. Divide both up by what? By 5. So x equals negative 3 over 5 or negative 0.6. So, gentlemen, these are most of the questions that you can ever expect in any simple quiz. I've covered it all. I know it took me like 18 and 5, 22 minutes. I can give you more examples until you are sick of me. Do you think I have more? I've looked through your worksheet. I looked through your lecture notes. I found everything that you could expect to see. Can I make more questions? No, let me see. I really don't have any. How about making something ugly? This is 6, 7. Let's make it question 8, the last one. All right? I hope I don't have it wrong. No, I'm not going to be trapped in this one. I'm going to look at my notes somewhere here. This is from your lecture note. Okay. Okay. I'm going to choose something some people think is ugly. 0.001 equals 0.1 to the power x minus 1. I know people, when they see decimal, they always go to calculator. It's funny question, simple. What is 0.001? It's 1 of 1,000. What is 0.1? 1 over 10. Why don't we make it simple? No, harder. 0.01. 1%. هذه 1/1000. So 1 over 100 all to the power x minus 1. What 1,000 means? 1,000 means 10 to the power 3. All right. And 100, 10 squared. People don't like these things. You know why? They think it's a 10 to the power 2. This one, 10 to the power 1. It's not. How many zeros you make the power? So remember these secrets. Let's take them up. 10 to the negative 3. How about that one? 10 to the negative 2. But don't forget. Expand the bracket. Leave this one alone. Minus 2 times x. Negative 2 times negative 1. Are the bases the same? Yes. So, negative 3 equals negative 2x plus 2. Put the x on the positive side. Take the 3 over there. 5 over 2, x equals 2.5. Don't you feel that? How come the teachers know everything? No, practice makes perfect. How do I know as a student this is correct? No problem. Plug it in there. Take this number and put it here. And hope when you plug it there, let's find out. What's 2.5 minus 1? 0.01. All right? To the power, open bracket. 2.5 minus 1, close the bracket. I hope that it will be something like that. Yes, 1 over 1,000. That's what I see the calculator. It means that one. So your bad knowledge of this equals that, that's a problem. Some people don't know that 1,000 is 1 over 10 to the power 3. They think 10 to the power 2. That's another problem. So remember, indices is the heart of algebra. What comes after that, a big question. Very big question. I will not solve it now. This will be taught in the middle of or at the end of the week, inshallah, before the Eid. Ask yourself the big question. If what I say is right, how can I solve this? How can I solve this? Thank you very much. Think about it. This is your little chapter. You won't be able to do it now when you go next chapter, but think about it.